that?
Awesome. Wow. We have something ready. Okay, everybody can see? Do I need to angle it a little bit? Can you see
That's
it over
good.
there in the corner? I guess if I sit
I
down.
guess people that want to see can see.
All right.
Okay, which one you pulling up?
This is something I did,
Oh,
but yeah, it does have examples, and I forgot to go through them. But
shame on you.
I'll do my own thing here. My name's Ben Bradley. For anyone who doesn't know.
Oh yeah, this is Ben. Sorry.
I have this T-shirt. I went to the seminar in Atlanta in 2009 on LTspice. And it was put on by the guy who wrote it and developed it and maintains it. I forget his name.
He's a European guy.
He's
Holland, something like that.
I forget, but
I'm still on his.
it was originally named SwitcherCAD, if you remember that name. But it's LTspice is from Linear Technology. It's a perfectly general spice program. It was originally done because they wanted to have some simulation program for their switching power supply chips. But now it comes with a model of just about every Linear Technology semiconductor that they make, including all of their expensive op amps. But since it is general, you can take models from any kind of spice model and put it in here. I've found this tutorial which is from this site. You can read that. Simon Bramble, SIMONBRAMBLE.co.uk. And it's pretty short and covers the basics going pretty fast. But I'll get to that in a minute, I guess. But starting from scratch with a new schematic, you've got resistors, and you can hit Control R to rotate it 90 degrees. And it comes with a default value of R, which you would want to change, put in a numeric value. Control R.
How'd you get one of the tapes? Thanks.
And you right click on the resistor to get there, or you can right click on the value to have the value come up. Either way. And what you don't want to do is put in that capital M for M. It gets converted to lowercase m, which you probably mean meg or 10 to the 6th power, but it takes an M as milli or 10 to the minus third. So that's a little bit of a defect in it.
So you just always got to do K, like 2000 K?
Yeah.
I don't think that's a defect, I think that's intentional.
Or you could do,
It's a feature. Usually small m means below, decimal point, and big M means big numbers.
yeah. And I typed in capital M, but it shows up as lowercase m.
That's a
It has a,
Yeah,
oh,
and these icons are pretty strange. There's the scissors to delete. I've escape gets you back to this. You can hit the delete key to get to the scissors. I've found this user interface to be a little bit funny, but I've gotten used to it.
The big thing that took me to get used to was the use of the function keys. It uses a lot of the function keys, which is something you just don't see since the 80s.
I guess that's good, but I really haven't used them. I just go by the icons and stuff.
well, a lot of CAD systems out there, the CAD/CAM systems, will have background function keys you can use, even though there's pull downs to do it.
Right. Well, I don't know of a way to get to, say, like a voltage source without using F2. Is there a way to get to a voltage source without using F2?
Yes. Since we're going there,
Okay, that's the F2
symbol.
menu. That's the F2 menu right there. Okay, so that's how you get to it.
Wait, how'd you get there?
the little NAND gate symbol.
Yeah, it is
Wait, that
very
doesn't
obvious.
create an
I mean, I've used this before.
I would have never thought you got a voltage source from going through a NAND.
Yeah, exactly. I always had a hard
Okay.
time finding it. I use it so infrequently,
Okay,
I always
we-
forget.
Yeah. But that same menu is F2.
Okay.
Where I was going with this was putting the C value here, capacitance. You can put 4.7 U and using the lowercase level u, letter U, or probably even the uppercase letter U, it converts it to the Greek letter micro. And you can put microfarad if you want, just to show what the unit is, but it knows it's a capacitor and it knows it's in farads. You can hit this grab thing here, the hand thing, and then rotate it and move it around. And we've got this wire thing to hook things together.
Wires are always good.
Yes.
It's definitely not intuitive.
Yeah, you really need to hit escape between each wire.
Yeah, you need to click on the wire, and when you've got the cursor that goes all the way across the screen, that's where you've got it. You just
Right click, left click,
left click, regular click, and then
drag.
But sometimes you want to leave a little leader of wire down so that you're away from the initial point where you contact the component, so that when you move the component, if you have to rearrange things, you don't have the entire trace following you everywhere.
Right.
You kind of want to leave a little bit of a grid separation.
go to the terminal, and then left click. Nope, you did the wrong. You did
Oh,
something.
I used my right, didn't I?
Oh, okay.
I always get them.
And you drag horizontally or vertically, and then you click again,
Oh,
and it'll change direction.
who wrote this? An engineer?
I'm
Electrical
I'm
engineer?
afraid so.
Well, think about it. Would a programmer really know schematic capture?
Depends on their background.
Yeah.
Has anybody written
background
like an
being
interface go to like a wrapper to go
Oh.
around this?
Well, the good news is
Yeah.
So is this like used a lot in industry or?
It's probably the most popular freeware spice out there.
Well, so let's back up and explain to me what spice is.
Oregano,
uh-huh.
rosemary.
Basil.
It's a simulation for electronics.
Okay.
Probably the most famous one out there is P-Spice. And
Yeah.
it was developed, the original spice was developed by Berkeley
Okay.
in California. And it is freeware out there if you buy the original one. But different companies will take the Berkeley version, massage it into what they want to be, and we've got many different flavors of spice out there, but LT is the most famous of the free ones.
Probably the most popular free spice.
Originally, spice modeling was all text notation. You would have to use a text editor, and you had ways of labeling nodes, like in mesh analysis or nodal analysis.
That's how we have to do it.
All your components, and you would create a circuit with text. But now, with the schematic capture, it has become so popular in the last decade and a half, and so easy to do. Actually, he's showing you the kind of text file you create for doing a schematic. That's similar to what a spice text might look like.
Okay, so are you just designing a schematic here, or can you turn it on?
You can turn it on
It's
and
both,
put
yeah.
functions
Yeah,
into
You
it.
can blink an LED in.
Yeah.
Yeah.
Okay.
Oh, let's do that.
Well, I've never seen an LED blink, per se.
Well,
A lot of people, you think of it as an oscilloscope in simulation. That's what you get. You get frequency domains, which would be like spectrum analysis, and you get time domains, which would be like oscilloscope, and you can see all your nodes that you want to look at simultaneously, time-wise or spectrum-wise.
Okay. Has anybody used virtual breadboard?
Heard of it.
is that one of the ones on the web? It's a website.
VVB, it's by,
There's,
I forget the guy's name.
there are several rather simple, I think, simulation programs that are just websites. You draw a schematic on the web and it simulates it on the server. I don't remember one offhand. It's been a while since I've seen them.
Now, there was another one for Android, I think, the circuit. Dale, did you play with that? The circuit simulator?
It's been several months or about a year.
Circuit Lab? Was it Circuit Lab?
Trying to see if I
That
can-
sounds right.
You can also do schematic capture in Eagle and then import it into LTspice.
Right.
Yeah, that's what I was going to say. You can do schematic capture on any spice program and import it to this. And that it writes this spice format. And you can see where it says wire, and that's the start and end positions of every horizontal or vertical wire that it has
Now,
in there.
Did you write that, or did it create that file
It
for
created
you?
that file from the schematic.
Yeah,
Just
well,
from that schematic,
Not,
right
not
there.
this one, but
A different one.
this one.
Okay.
But what you were just showing us was more the physical representation on the schematic, not the actual spice model itself.
Right, this is, yeah, this is
Let's
the,
let him keep moving.
Yes.
okay, this is what it says when you save the schematic. But, okay, keep moving. This, if you click on the, okay, we've got components here: resistor, capacitor, coil, inductor, whichever, diode, and then the NAND gate is component, which is everything else. And one we want to go through is voltage, the next to the last one. And then put it here, then you can right click to make the symbol go away. You can place several of them if you have here, and you can see where it automatically labels the V2 and V3. You can hit the delete key and the scissors come up and you can delete them, then hit escape. And I want to wire this up. And the trick here is to go click, then go vertically, click, then horizontally, then click. I can show that again. Click on the wire, click here. You go to that point and click, and it'll automatically change directions. And when you get to an end point and click, it no longer follows you around. You can start a new wire. there's a circuit, we can put this at 1 volt. And we have a circuit. You can hit run and it brings up a command editor thing. And we get various options here. Let's see, stop time 1 second. Is this what we want to do? Well, let's see what this does. There's another little thing. The first of several little thing gotchas. It needs a ground symbol somewhere. For some reason, it needs some node connected to ground before it will simulate.
That's
Think it is, but
probably
Not
for
in
the
Spice.
probe, probably
Yeah.
for your to know where your probe, your scope
Yeah,
is.
yeah, it'll need that to know when you probe various nodes, which node is relative to, and it'll be the ground.
Although there is differential probes available too.
Okay. I'll get rid of this one. And here we are, and we've done a simulation. If you, after a simulation, things kind of change a little bit. You click on your schematic and go over a wire, and it becomes a probe. You click on that, and it draws the plot of that versus time. And of course, this is at 1 volt. This one is also at 1 volt, or so it appears. But I'm sure somewhere in here.
Looks like a little bit less than 1 volt if you look at that.
See, I can't even see it. You can delete these. I right click to bring this up and then delete. Yes, there is something in the simulation. Simulations are a bit strange. There are see, is that what I want? Start external DC fly voltage at 0 volts. That sounds about right. Yes.
Here you
Yes.
see.
This looks better. You can zoom in and you can see the curve as the capacitor voltage charges up towards the battery voltage.
What did you do differently then?
We had to start the simulation at 0 volts, so the capacitor, you can see the capacitor charge up.
Okay.
It was already charged up when he hit, I guess, like a run.
Yeah, if you
How do you change the under control? Is it,
He's going up into an editor, and there's actually an option for start
edit
external.
simulation command, okay. Start simulation.
yeah, that's under simulate. And when you add a simulation, it puts the text under here. And you can get to this menu by right-clicking. There's a plain text, then you could put text into with this. Next to that is this. Did I click that?
What is that?
Which puts in a SPICE directive, supposedly.
So what would be your SPICE directive?
That, but it's, let's see what it does.
Does that just do your, doesn't that do your frequency? If you want to run it for so many milliseconds at And changing your frequency along that time base.
Oh, let's see, where were we? Here's a stop time of 1 second. We can make it much shorter, 0.01 of a second. Or 10 for 10 milliseconds, as opposed to megaseconds. And we see we can click on a trace and click on a cursor and drag it. The node 1 stays at 1 volt. This one you can drag it to see where it says 2/3, and it takes 1.027 milliseconds to get there. And if that's not accurate enough for you, you can zoom in and do this, and it says 1.043 or so.
I presume you can also type in what you want and click enter or something, and it'll show you where it is on the graph.
I don't know. I guess not.
Type in your horizontal. Sometimes that'd be your X. No? Okay.
But you can keep zooming. But you can drag to any position and see the numbers.
Mm-hmm.
I want to do a new schematic. And this one is going to have an op amp. And under the component menu, there's these in brackets, and they are effectively folders, subfolders, and one of them is op amps, and these are all linear technology parts, except for these, which are for models, for including other models. But these start at a couple dollars each, I think.
That's a lot.
But I'm going to draw this real quick. And I'll show another problem. And this one does not give an error message. And we're under op amps again. You see the two dots. If you remember DOS, where you do change directory ... to go to the higher directory, you click on that and you go back to the main directory. You get a voltage source. And I am going to click on here, you can click advanced, and you come up with this menu of different types of waveforms this voltage source will generate. See, 0 offset, 1 volt amplitude, frequency of 1000 hertz. This is a sine wave. And 10 cycles, which should go for 10 milliseconds. Stop time 10 milliseconds. I think that's all I need.
Do you need to start at 0?
Need a value.
Okay. These resistors need values, of course. And here's our input, and since this is an inverting circuit, the output should be flipped over out of phase. But it's not. Does anybody see what I missed?
Another,
That right there,
You have the negative
and
open.
that right there.
You have to power the op amp?
Yes. It needs 2 more power plus and minus sources here.
2 or 1? You need 2.
So I can wire these up in various ways. I'm going to create a label. With,
You got one of the pluses grounded and one of the minuses grounded.
well, well, you can put in any voltage you want. I'm putting in 15 for this one, and for this one, I'm putting in minus 15.
Okay, gotcha.
Or I could turn it upside down and put 15 in it. But yeah, we've got these little net names, what they call it. I call it a label, but I'll label this 15V. I'll label it plus 15V. Put one here and put one here. And now they're connected like, as if they're a wire, but this is a little bit
virtual
neater.
Connector.
I've heard these called bubbles. You know, people use circles and label them A or B or something.
Yeah.
And simulate. And it's upside down now, it works.
Yay.
I can change this to a lower value and the output should be a lower amplitude.
Yay.
Yeah. And again, you can get the voltage at any point here.
So this would be great if you need a particular type of signal to go into one of your sensors. And you're trying to build a circuit so you get the right signal in there.
Yeah, or if you're have a sensor that you know gives out a certain voltage or has a certain resistance, you can make this circuit and make an amplifier for it.
Mm-hmm.
So that appears to be a long supplier.
Yes.
Picky.
10-to-1 reduction.
Okay,
Continuator.
It's a negative transamplifier.
something like that.
You can simulate your sensor
Make it a game.
stuff on this if you want to have the minimum pulse width of what you want to read. If you want to amplify that with your own transistors, put your transistors in there. And obviously you want to buy the transistor of the model you're using, because they do try and get the exact characteristics in this model, so you actually get real life representation of what your transistor circuits are going to do.
Yeah, but it can get more complicated than that, because there could be a dozen different models for one specific component depending on what kind of analyzation you're doing. You may have one for high frequencies, another one for medium frequencies. You may have one for temperature drift, where it does a better job of simulating temperature changes in your component.
Well, I thought if you just buy LT's part number of this op amp, they're going to have that model in there. If you hit it with this frequency.
When I took a spice modeling class at Southern Polytech, they made it very clear to you, the models you get, one size doesn't fit all for that component. They're depending on what you're looking for. But at our level, it's not really that important. We're not worried about temperature here and stuff like that. In a more engineering level, where you're making something that may ship thousands of pieces, you're more concerned with that sort of thing.
Yeah, it's Depends
what
on
they
how
have
deep
there is
you
good
want-
enough for robotics, that we do.
Yeah, depends on how deep you want to get into this. Here's a